Hi all. This is a video to deal with AP Review Packet 3, Velocity and Acceleration. Let's jump right in. Problem number 1, squirrel starts at a building at time equal to 0, travels along a horizontal wire connected to the building. There's 18 seconds of velocity given by a piecewise linear function shown above. On what intervals, if any, does the squirrel change direction? Well, this is velocity. And if I'm looking at velocity, I see that velocity from 0 to 9 is positive, and velocity from 9 to 15 is negative, and velocity from 15 to 18 is positive. Where velocity changes sign, that's where the squirrel changes direction. Squirrel changes direction at t equals 9 and t equals 15 because v changes sign at these times. Okay, B. At what time is the squirrel furthest from the building? How far from the building is the squirrel at this time? Well, we've already identified some candidates for minimums and maximums, so we need to do the full candidates test here. Our integral from 0 to 0 of v of t dt equals x of 0, which is 0, and the integral from 0 to 9 of v equals, that's 1/2 a height of 20, base 1 is 9, base 2 is 7, minus 2 is 5. And so I get 10 times 14, or 140. And the integral from 0 to 15, well, we see positive to negative, so we know that's a max. But really, I can't just use that there's a max there, because there's also a max over here at 18. And so I have to do my candidates test. You might be able to toss this one out and say, yeah, I know there's a minimum at t equals 15, so I'm not going to consider that with the candidates test. But, you might as well just find it because it's 140, the integral from 0 to 9, plus the integral from 9 to 15. And that's 4 plus 6. And so that's negative 50. Is that negative 50? Because we're below the x-axis. So that's 90. And the integral from 0 to 18 of v is going to be 140 minus 50 plus the integral from 15 to 18 of v. And that is another trapezoid. So we've got we've got 90 plus 1/2, 10, and then that length is 2, and that length is 3, and that's a 1/2. So we've got 5 times 5 is 25, and that's 115, and so there's my max distance away at t equals 9 seconds. Okay, total distance the squirrel traveled. Oh, well, we've got all these convenient numbers. So the total distance was 140 plus 50 plus 25, 5 times 5, 25. 190, 215. I had 265 before. I better check again. Yep, 215. That's good. Okay, so there's part C. And do we have units on this? No. So 215 is the total distance traveled because it's the absolute value of all these distances. And then we want part D, write an expression for velocity, acceleration, and position. Well, in order to write velocity, and they've given me a graph of velocity, I've got these two ordered pairs, 10, negative 10, and I see that it's a linear function in between them. So I have to write the equation of the line. I'm going to have 20 minus a minus 10 over 7 minus 10, which is 30 over negative 3 or negative 10. And then y minus 20 equals negative 10, x minus 7. So y equals negative 10x plus 70 plus 20, or negative 10x plus 90. They wanted velocity as a function of time, so v of t equals negative 10t plus 90. Okay, a is the derivative of this function, so that's just negative 10, or this slope that we found, a of t. And then they want x of t. Well, x of t on 7 to 10. X of t minus x of 7 equals the integral from 7 to t of v. Oh, so not enough letters. D. I can't use x. I can't use t. I'm just going to say that. Okay, so we need to find position at 7. And position at 7 is 1/2 a height of 20. And the first base is 5, and the second base is 7. So 10 times 12, or 120. So x of 7 equals 120. Now, why do I want that? Well, I know that I need the antiderivative of v. So here's my v function. I do the antiderivative of that. X of t is going to be negative 5t squared plus 90t plus c. And then to find that c, I'm going to plug in this ordered pair. Notice I have to use 7 because they gave me the interval on 7 to 10. So this is the starting point of that interval. I mean, I guess I could use 10, the ending point of that interval. But to me, it made more sense to do this. So I'm going to plug in 120 here, and a negative 5, 7 squared plus 90 times 7 plus c. And when I computed this, I found that c was equal to negative 265. So then x of t is negative 5t squared plus 90t minus 265. And that's problem number 1. Okay, problem number 2. Let's take a look at that. Particle moving along the x-axis. Velocity is given by v of t. On 0 to 12, when is the particle moving left? So if I think about the graph of this function, and luckily we spent a lot of time graphing cosine functions, I set pi over 6t equal to 0 and pi over 6t equal to 2 pi, and I get t equals 0 and I get t equals 12. So 0 and 12, and we've got v, which is this cosine function, and quarter points. Cosine starts high, goes low, and then back up again. And so this would be 6 and 9 and 3. When is the particle moving to the left? Well, particle moves left when v is less than 0, so on 3 to 9. And there's part A. Part B. Write but do not evaluate an expression that gives the total distance traveled, 0 to 6. Okay, so the integral from 0 to 3 of v of t dt minus the integral from 3 to 6 of v of t dt. Right, I have to subtract that negative amount, and pay attention, they're telling here the total distance traveled from t equal to 0 to t equal to 6. So we're not going all the way out to 12, we're just doing 0 to 6, and we have to subtract that negative quantity off. So there's our total distance traveled on 0 to 6. Okay, part C says, find the acceleration of the particle. Is speed increasing or decreasing at t equal to 4? Okay, so if v of t equals cosine pi over 6t, then a of t is going to be pi over 6 times negative sine pi over 6t. I'm using chain rule here. I took the derivative of the outside and I left the inside alone, and then I came back and took the derivative of the inside function, which actually I took the derivative of the inside function and then multiplied by the derivative of the outside. Okay, so we need v of 4, which is cosine pi over 6 times 4, which is cosine of 2 pi over 3, which is negative 1/2. We need a of 4, which is negative pi over 6 cosine, sine of 2 pi over 3, right? Because we're plugging a 4 in here, and 4 over 6 is 2 over 3. Sine of 2 pi over 3 is root 3 over 2, and so we've got negative pi over 6 times root 3 over 2. And what I can see here is that velocity is negative and acceleration is negative, and since v of 4 and a of 4 are both negative, speed is increasing. Okay, so we've got speed is increasing there. Part D. D says find the position at t equals 4. So we know that x of 4 minus x of 0 equals the integral from 0 to 4 of v of t dt. Yeah, I know that at time equal to 0, position is negative 2. So x of 4 minus a minus 2 is plus 2 equals the integral of v from 0 to 4. So let's talk about the integral of v. That's the antiderivative of v. So the antiderivative, and you can do this as a u sub where you have pi over 6t for your u. So you should end up with 6 over pi sine pi over 6t. If you don't see how I got that, do the u sub. You'll be happy you did. So here's x of t plus a constant. Do I need the constant? Oh, I'm evaluating x of t. X of 4 minus x of 0. And so our t's won't matter. And what do we get here? Well, we plug in a 0 here. Sine of 0 is 0 times that constant is 0, so that's not going to be an issue. And so I just need to plug in a 4, and that's going to be 6 over pi. Sine 4 times pi over 6 is 2 pi over 3. That's root 3 over 2, so 6 over pi root 3 over 2. That's going to be x of 4 minus x of 0. But remember, x of 0 is in fact this other thing called negative 2. Because we never found that c value, so I really need to plug in my negative 2 here to say that x of 4 equals 3 root 3 over pi minus 2. What an interesting position. Okay, so there's part D for number 2. Let's take a look at problem number 3. Problem number 3, v is given by negative 1 plus e to the 1 minus t. Find acceleration at 3, so a of t is e to the 1 minus t times the derivative of the inside function, which is negative 1. And a of 3 then is negative e to the minus 1 minus 3 is minus 2, or negative 1 over e squared. Okay, there's a of 3. That's part A. Part B. Is speed increasing or decreasing? This seems to be a popular question, so we need to know v of 3. V of 3 is going to be negative 1 plus e to the minus 2. That's negative 1 plus 1 over e squared. This is less than 0. This is less than 0. And since both of these are less than 0, we know speed is increasing because v of 3 and a of 3 have the same sign. Okay, part C. Part C says find all the values where this thing changes direction, so I want to set v equal to 0. You know, often this statement here earns 1 point on the AP exam, where you identify that I need to find these critical points by setting velocity equal to 0. So if I set this velocity equation equal to 0, I'm going to add 1 to both sides, e to the 1 minus t. And then I'll take the ln of both sides, and I'll get 0 equals 1 minus t, and so t equals 1 is a critical point. So 0, 1, v. Let's see what I can plug in here. If I plug in a 1/2, this is without calculator. I need some sort of test values. Well, what if I plug in a 0? If I plug in a 0, I get e to the 1, which is positive 2.7, minus 1, that's positive number. And if I plug in a number on the other side of this, then 100. Then I get e to the minus 99th, positive minus 1. Well, that's 1 over e to the 99th. That's 0 minus 1, which is negative. So particle changes direction at t equals 1 because velocity changes from positive to, I hate writing that, because velocity is greater than 0 to the left of t equals 1 and less than 0 for t greater than 1. Okay, so there's number 3, part C. What about 3D? Find the total distance traveled on 0 to 3. Well, we already identified that we had this positive and negativeness here, and so total distance will be the integral from 0 to 1 of v minus the integral from 1 to 3 of v. Find the total distance. Okay, so I need to integrate v. I need to integrate v. Oh, that's going to be a pain in the butt, isn't it? Okay, so I've got v equals negative 1 plus e to the 1 minus t. Then we say that x is negative t minus e to the 1 minus t. And again, if you don't see how I got this part, do a u sub where u is equal to 1 minus t. Okay, so we need x of 0, which is 0 minus e to the 1, or negative e. And we need x of 1, which is negative 1 minus 1 minus 1 is 0, e to the 0. That's negative 1 minus 1, which is negative 2. And we need x of 3. And x of 3 is going to be negative 3 minus e to the negative 2. Okay, so let's take all this stuff together. Now that we have these elements, we know that this one would be x of 1 minus x of 0. And then I want to subtract from that x of 3 minus x of 1. So we've got negative 2 minus a negative e minus x of 3 was negative 3 minus e to the minus 2 minus a minus 2. Oh boy, sign fun. So that's negative 2 plus e minus negative 3 plus 2 is negative 1 minus e to the minus 2. And then I've got negative 2 plus e plus 1 plus e to the minus 2, which is negative 1 plus e plus 1 over e squared. Yay! Could you have left it here? I think so. You can't leave it here, but you could definitely stop here, and that would probably save you a lot of stress. Okay, let's take a look at problem number 4. Okay, problem number 4 says particle moves along the x-axis given by this differentiable function v, whose graph is shown. Velocity at 0 is 0 at 0, at 3 and 5. Graph has horizontal tangents at 1 and 4. Areas are 0 to 3 is negative 8. From 3 to 5, the area is 3. And from 5 to 6, the area is 2. Okay, so what do they ask? Find the time and position the particle is furthest to the left. So I want to identify some candidates, and I want to consider x of 0, x of 3, x of 5, and x of 6. X of 0 at time equal to 0, we're told we're at negative 2. And then we move negative 8, so negative 2 plus negative 8 is going to be negative 10. And then That's negative 10. We move up 3, so negative 10 plus 3 is negative 7. And then we move down 2, so we've got negative 7 plus, minus 2 is negative 9. And we could think about each of these as integrals, right? So x of 3 minus x of 0 equals v from, the integral from 0 to 3 of v of t dt. And so we know that x of 3 equals that negative 2 plus the integral from 0 to 3 of v of t dt. And then I was saying that x of 5 minus x of 3, because we just found x of 3, would equal the integral from 3 to 5 of v of t dt, which is why I just used that area number of 3 here, and then subtract 2 from that, the position, I'm sorry, not 2, added x of 3 to both sides. So x of 5 equals x of 3 plus that area of 3. And so we've got negative 10 plus 3 is negative 7. And that's what I showed there. Okay, so when are we furthest to the left? That's what they ask us here. We're furthest to the left at t equal to 3, and x of 3 is negative 10. So there's part A, a candidate's test. Part B, how many times on that interval is x equal to negative 8? Well, we were at negative 2, we went to negative 10, and so there must be a negative 8 in there somewhere, according to IVT. We were at negative 10, we got to negative 7, so guess what? There must be another negative 8 in there, according to IVT. Remember, IVT is the fists, and since this function is continuous, well, we know it's differentiable, and therefore it's continuous, on this whole interval, this function is continuous between 3 and 5, and therefore IVT says there must be at least one point where we go from negative 10 to negative 7 and pass through negative 8. And then finally I notice going from negative 7 back to negative 9, we must pass through negative 8 a third time. And so how many times? 3 times. 3 times v equals negative 8v. No, x. X equals negative 8 because of IVT. Since since x is continuous on 0 to 6. Okay, there's part B. What about part C? Is speed increasing or decreasing on 2 to 3? On 2 to 3. 2 to 3. So let's take a look at velocity from 2 to 3. So here's 2. This is the velocity curve. Velocity is v between 2 and 3, or v on 2 to 3 is less than 0, right? We see the velocity curve is below the x-axis. But what about a? Well, a, acceleration, is the derivative or slope of velocity. And from 2 to 3, I see that on 2 to 3, we have a positive slope on the velocity graph. Because v and a have opposite signs, speed is decreasing on 2 to 3 because v and a have opposite signs on those intervals. And maybe instead of saying those intervals are that interval, we just say on 2 to 3. That seems more precise. And then finally, part D, on what intervals is acceleration negative? Well, we said acceleration was the slope on this graph. We have a negative slope from 0 to 1, and we have a negative slope from 4 to 6. So those would be places where A is less than 0 because the slopes of V are negative, or because V is decreasing on 0 to 1 union 4 to 6. Okay, what's next? Problem number 5. Problem 5 says acceleration, oh, and this is with calculator. Don't do things when it's with calculator by hand. Okay, so we're told that V equals the ln of t squared minus 3t plus 3, and I want to know A of 4. So I want to take dv dt and evaluate it at t equals 4. That's all I need to show, and then I'll pull out my calculator and I'll type in ln of x squared minus 3x plus 3, and then I'll go to the main screen and I'll do an n deriv of y1 comma x comma 4. Invalid. N deriv y1. What? I'm confused by the notation suddenly. Why don't you like that, little calculator? Oh, because I put it in y2. You silly. Okay, so I'll go back over here. Variables, y2. There we go. So we get 0.714. Okay, do we have units? We don't have units, so I'm not worried about that. I'm just moving on. Divided by 7. Oh, isn't that interesting? When I did this in my notes, I actually went the long way and took the derivative of this by hand and plugged in a 4. And so you have 1 over t squared minus 3t plus 3 times 2t minus 3. And I evaluated that at t equal to 4. And I got the same thing. But I thought since it's the calculator portion, it would be good to just have you focus on set up the notation, and then use your calculator. Okay, part B. Find all the times on the interval when the particle changes direction. So I need to take a look at this graph on the interval from 0 to 5. 0 to 5. And I'm looking at the graph. And I see I go below and then back above. I need to find when does the particle move left? When does the particle change direction? Okay, so second, calculate 0. You know, I've got a lot of y here. I think I'm actually going to take the time to change this to be negative 1 to 1 so that I can better see these points. Oh, look at that. They're actually at 1, 2, 3, 4, 5. They're at 1 and 2. So change direction at t equals 1 and t equals 2 because velocity goes from positive to negative or negative to positive at these times. Okay. During which intervals is the particle traveling to the left? Particle moves left on 1 to 2 because velocity is negative. 1 to 2 because velocity is less than 0 on 1 to 2. Okay, so that's the second part, part B. What about part C? Find the position at t equals 2. Find the position at t equals 2. So x of 2 minus x of 0 equals the integral from 0 to 2 of v of t dt is how I want to think about this problem. What are we told? We're told that position is 8 at time equal to 0. So x of 2 minus 8 equals this integral from 0 to 2 v of t dt. Please, by all the gods, do not try and do this by hand. Instead, come up here and do math f int. Of I learned my lesson, I'm in y2, comma x, comma 0, comma 2, and I end up with x of 2 equals 8 plus 0.3686, and so I get 8.369. That's x of 2. From this, we added 8 to both sides. Okay, so that's the position, part C. And what about part D? Average speed. Well, average speed is the average value of the speed function. So 1 over 2 minus 0 times the integral of the absolute value of v from 0 to 2. Now, the absolute value of v, I'm a little concerned. Well, I could actually just ask my calculator to do that, couldn't I? And so I can say, got that there, so I want 1/2 0.5 times f int of absolute value of y2 comma x comma 0 comma 2, and I end up with 0.371. If you didn't want to use absolute value here, and I'm not a big fan of that, you could do 1/2 of the integral from 0 to 1 of v minus the integral from 1 to 2 of v. And that will give us that total distance traveled for our speed function. Okay, there's problem number 4. 5. Problem number 5. Let's take a look at 6 and halfway through. Two particles move along the x-axis, 0 to 6. P is given by 2 cosine pi over 4t, and R is given by t to the third minus 6t squared plus 9t plus 3. And this is without calculator, so I'm going to put that aside. Part A, find all the times, and R is moving to the right. R is moving to the right. Okay, so I want to look at R prime. That's 3t squared minus 12t plus 9. I can pull a 3 out of each of those. 4t minus plus 3. And so I get t minus 1, t minus 3. And so my R prime sign chart, 1, 3, 6. And, you know, R prime is a parabola that points up. So I don't have to test values. I just know that a parabola with a positive leading coefficient is going to point up and go that way. So we've got positive, negative, positive here. Okay, so what were we asked here? Find all the times when the particle is moving to the right. R moves right on 0 to 1, union 3 to 6. Do we have to justify? No, we do not. Nice. That's my answer for part A then. Part B. Find all the times which the two particles travel in opposite directions. Two particles travel in opposite directions. Well, I know by looking at the velocity of r that r is traveling to the right, and then to the left, and then to the right. And so maybe what I want to do is do the same thing for p. Let's look at p prime. That's going to be 2 times negative sine pi over 4t times the derivative of that inside function, pi over 4. And so we get negative pi over 2 sine pi over 4t. Okay, this is without calculators, so I need to look at the graph of p prime. Pi over 4t equals 0, so t equals 0. Pi over 4t equals 2 pi, so t equals 8. I have these endpoints, and I've got a graph of negative sine. Starts at 0, ends at 8. There's 4, there's 2, there's 6. And we have negative signs, so we go down and then back up again. And so we've got negative and then positive. Okay, so there's p prime, and I want to compare that with r prime. So let's do r prime. We've got 0, r prime, to 1, positive, negative until 3, and then positive. Well, it looks to me like they're both negative from 1 to 2. But from 0 to 1, r prime is positive, p prime is negative, and so they travel in opposite directions on 0 to 1. And are there any other times? Well, from 3 on, this one is positive, but from 3 to 4, this one is negative. So I would say 3 to 4 as well. After 4, this is positive and this is positive, so they're both traveling in the same direction again. And we don't have to justify, so I just have to claim those two. Okay, so there's part B. What about part C? Find the acceleration of P. The acceleration of P. I wish I hadn't erased my P prime. Let's see. P prime was negative pi over 2 sine pi over 4t. Okay, that's p prime, and so I need acceleration. I need p double prime. That's going to be negative pi squared over 8 cosine pi over 4t. And they ask us about at t equals 3. So p double prime of 3 is negative pi squared over 8 cosine 3 pi over 4. Well, cosine of 3 pi over 4 is negative root 2 over 2. So negative times a negative gives me a positive root 2 pi squared over 16. Okay, I found the acceleration at time equal to 3. Oh, look, are we speeding up or slowing down? And so we need to find p prime of 3. So that's negative pi over 2 sine pi over 4 times 3. That's negative pi over 2 times positive root 2 over 2, or negative pi root 2 over 4. This guy's negative, this guy's positive, and because they have opposite signs, because v of p at 3 is less than 0 and a of p at 3 is greater than 0, speed is decreasing at t equal to 3. Okay, so we talked about speed increasing or decreasing, or actually speed is decreasing means slowing down. Okay, and then write but do not evaluate an expression for the average distance between the two particles. Well, I've got this situation where at one time one particle is above the other particle. And then they switch. And so the distance between them is this distance. And I guess I could split this up as two integrals, figuring out when this function is above this, and then a second integral from here to here when this function is above that. But I think I would rather do 1 through minus 1, integral 1 to 3 of p minus r dt. And of course, you could do 1 to 3 r minus p dt because it's absolute value. So that would be my integral expression for part D on number 6. Part D on number 6. Let's take a look at 7. 7 says the rate in calories per minute people using exercise machine burn calories is modeled by this polynomial function f equals negative 1/4 t to the third plus 3/2 t squared plus 1 on 0 to 4. Okay. And is piecewise linear from 4 to 24. Oh, so this is the graph of calories per minute. And calories per minute is a rate. Ooh, so if I integrate that rate, I'm going to get calories. Okay, so what's f prime of 22? So f prime of 22 is the slope of f at t equals 22. That means I'm going to use the slope formula between the ordered pairs 24, 3 and 20, 15. So 15 minus 3 over 20 minus 24 is 12 over negative 4 or negative 3. Now, what are the units here? Well, the units on F are calories per minute. So these numbers are calories per minute, and these numbers are minutes. So I have calories per minute on top and minutes on the bottom. You could write negative 3 calories per minute squared, but I don't know what that means. And I know what it means to say, hey, my rate is decreasing by 3 calories every minute for each minute that goes by. Okay, so indicate units of measure. We did that. That's part A. Part B. On the time interval 0 to 24, f is increasing at the greatest rate. F increasing. So f is increasing on 0 to 4 and on 12 to 16. That's when f is increasing. So when is f increasing the greatest? Well, on 12 to 16, we have this linear function. So I'm going to find the slope there to find what the rate of change in f is on that interval. 15 minus 9 over 16 minus 12, which is 6 over 4 or 3/2. And now let's take a look at big F prime with our polynomial function. So f prime up here is negative 3/4 t squared plus 3t. Okay, I can pull out a -3 here, and I get 1/4, ooh, and a t, 1/4 t minus 1. And I set each of those equal to 0, and I get t equals 0. And what about this guy? 1/4 t minus 1 equals 0, 1/4 t equals 1, t equals 4. So I've got these values at 0 and at 4 that I need to find out what f prime is. So if I go back to my f prime function, oh wait, I know that, I'm sorry, I need to know what f is at these places, don't I? No, slope. Where is slope the greatest? Oh, where's, oh, silly me. I don't need to find the intercepts of this. I need to find the vertex of this down-pointing parabola. Look, f prime has a maximum at minus b over 2a. So that's going to be minus 3 over 2 times -3/4, wasn't it? These cancel, and so we get 2. Well, 2 is greater than 3/2, and because 2 is greater than 3/2, f prime is max at t equals 2. Do we have to do anything else about justifying? Show the reasoning. I've shown some reasoning. Okay. Part C. Part C says total number of calories on 6 to 18, not 0 to 18. So I want to integrate from 6 to 18 f of t dt. That's integrating this graph. So I've got a rectangle from 6 to 12 of f, plus I've got this trapezoid from 12 to 16 of f, and then another rectangle from 16 to 18 of f. Okay, so rectangle from 6 to 12, 12 minus 6 times a height of 9, plus trapezoid, 1/2, 16 minus 12, that's the width or the height of the trapezoid, and then base 1 is 9 and base 2 is 15, plus 16 to 18 was another rectangle, so 18 minus 16, the width of that rectangle, times the height of that rectangle. You could leave your answer like this, but I went further and came up with 132. So we've got 132 calories burned on T equals 6 to t equals 18 minutes. Okay, there's part C. Part D. Getting on the machine is now changed to f of t plus c. Oh, so we're shifting this whole graph up, so we're going to be burning more calories. Okay, for this setting, find C so that the average of 15 calories is burned on 6 to 18. Okay, so average value, so 1 over 18 minus 6, integral of f from 6 to 18, but it's f plus c because we shifted everything up. So that's 1 over 12 times the integral from 6 to 18 of f plus the integral from 6 to 18 of c. Well, we just computed this number to be 132, right? That was how many calories were burned from 6 to 18. And this, the integral of a constant, is a rectangle, b minus a 18 minus 6 times c, or 12c. So let's see what we can do here. We've got 15 is the average number of calories burned, 15, and that equals 1 over 12 integral 132 plus 12c. You know, you could distribute the 1/12. You could multiply both sides by 12. This is without calculator, so whichever one looks easier for you. I know that's 11 plus c equals 15, so c equals 4. Okay, there's problem number 7. What about problem number 8? 8 says big F is equal to the flow. In fact, I'm going to write that up here. Problem number 8, big F is 82 plus 4 sine t over 2 for 0 to 30. Make sure your calculator is set in radians. To the nearest number, how many cars pass through the intersection? Well, big F is cars per minute. That's a rate. If I integrate that rate, I'll get total number of cars. So for part A, I want the integral of big F on 0 to 30. And I'll just pull out my calculator and evaluate that. This time I'm going to type into y1. 82 plus 4 sine x divided by 2. Make sure I'm in radians. Good. Okay, so math, integrate y1, comma x, comma 0, comma 30. Boink. 2, 4, 7, 4, and they said to the nearest whole number, didn't they? To the nearest whole number. So cars pass through the intersection on 0 to 30 minutes. And, you know, I kind of want to, I hear some of you say, shouldn't that be a this? Yes, I think that should be a that. Okay, part B for number 8. Is flow increasing or decreasing at t equals 7? Well, flow increasing, here's my flow function. I want to know if this f function is increasing or decreasing, so I want to look at f prime. And they say at t equal to 7. T equal to 7. So I want to know f prime of 7. So let's do math, derivative, y1, comma x, comma 7. And I get negative 1.873. Because big F prime of 7 is less than 0, flow is decreasing. Okay, what's next? What is the average value of flow on 10 to 15? Okay, average value of flow on 10 to 15. So we want the average value of the given function. That's 1 over 15 minus 10, integral 10 to 15 of f of t dt. Remember, this will integrate to cars. These are minutes, so we'll end up with cars per minute, and those were the units on f, which is why we have the average value of f. We're going to end up with cars per minute here. So if we go back and integrate our y1, but this time we integrate from 10 to 15, we get this number, and if we divide that by 5, I get 81.899 cars per minute. What does it ask me to do with that? Indicate units of measure. Right, so these were cars, and these were minutes, and so we had 409.496 over 5. These are cars, and these are minutes to get us that. Fabulous. There's part C. Part C. What about part D? What is the average rate of change? So that's f of 15 minus f of 10 over 15 minus 10. Okay, so I go over to my table, I put in a 15, I get 85.752, and I plug in a 10, and I get 78.164, and that's over 5. I think you could leave your answer like that, but I am going to take it a little further. 85.752 minus 78.164, and then I divide that by 5, and I get 1.5176. Now, what do we have here? Big F here is cars per minute, and these are minutes. So these are cars per minute on top and minutes on the bottom. Cars per minute, or cars per minute squared. Okay, there's problem number 8. Let's take a look at problem number 9. Problem number 9 says, particle moves with a velocity negative t plus 1 sine of t squared over 2. And yes, this is with calculator. Phew, I didn't want to do this without calculator. Okay, what do they ask me to find here? Oh, and a time equal to 0, position is 1. So x of 0 equals 1, I'm also told. All right, find the acceleration at 2. Is speed increasing or decreasing? So I need to find v of 2, and I need to find a of 2, and they don't need me to show any work here for finding a of 2. I just need to use my calculator. I'm going to type this function into y1, negative t plus 1, close those parentheses, sine of x squared divided by 2. Close those parentheses. Okay, so if I go to my table and I plug in a 2, I get negative 2.728. And to find acceleration at 2, I need the derivative of velocity at time equal to 2. And that's 1.586, since v of 2 and a of 2 have opposite signs, speed is decreasing. Okay, that's part A. What about part B? Find all the times when the particle changes direction. So I want v equal to 0 on 0 to 3. So let's take a look at the graph of v. I'm going to change the window to be 0 to 3. And I see negative, 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 lots of negative. Ooh, second, calculate 0. So I want to be to the left side of this point. Ooh, I'd like to see the point. There it is. Enter. The right side, enter, enter. And I get that 2.507, yes, 2.507 is my critical point on 1v. V is negative here and positive here. Okay, what do they ask me for? All the times when the particle changes direction. Particle changes direction at t equals 2.507 because to the left of t equals 2.507, v is less than 0, and to the right of t equals 2.507, v is greater than 0. Okay, there's my answer to part B. What about part C, the total distance traveled? Well, I see that this function goes below the time axis at above the time axis at 2.507. So total distance would be negative the integral from 0 to 2.507 v of t dt plus the integral from 2.507 to 3 of v of t dt. Okay, so we can compute that by hand. Math, integrate. I'm actually going to do this one first because I've got a positive integral and I don't want to go back and put in the insert negative. So I'm going to do y1 comma x comma 2.507 comma 3 minus the integral of y1 comma x comma 0 comma 2.507. And I end up with 4.334 is the total distance traveled. Not very far for you and me, unless those are light years. Okay, what about part D? During the interval 0 to 3, the greatest distance the particle is from the origin, and show the work that leads to your answer. The greatest distance the particle is from the origin. Well, remember we have this sign chart here that says, yeah. So I want to do a candidates test here. I think that's what they're hunting for. And I want to say x of 0, x of 2.507, and x of 3. So I need the position at each of these times. Well, and didn't they tell us the position at 0 is 1? Okay, so we know that this is 1. And this minus 0 is the integral from 0 to 2.507 of v of t dt. So if I add 1 to that integral, I'll get the position there. Okay, so math, integrate y1 comma x comma 0 comma 2.507. And don't forget to add 1 to that. So x of 2.507 equals negative 2.265. And then x of 3 minus x of 2.507 equals the integral from 2.507 to 3 of v of t dt. So I want to do this integral, and I will want to add this number to that integral to find x of 3. Okay, so I guess you could do 0. And that's 1, and we have to add 1 to that integral. So I'll go back and I'll do that. Integrate y1 comma x, comma 0, comma 3, and I end up with negative 2.197, and that's x of 3 minus 1. So we'll add 1 to that, and we'll get negative 1.197 x of 3. Okay, so where are we the greatest distance from the origin? That's the most negative number. It's bigger than this positive number, and it's bigger than this other, it's more negative than this other negative number. So this is when, and here's the work that leads to that answer. Great. Number 10. Last three problems. Number 10. 10 says average acceleration, but we're given velocities. So I know that average acceleration is going to be v of 8 minus v of 2 over 8 minus 2. V of 8, I read off the graph as negative 120. V of 2 is 100 over 6, negative 220 over 6, or negative 110 over 3. And the units here are meters per minute on top and minutes on the bottom. Negative 110 over 3 meters per minute, or negative 110 over 3 meters per minute squared. There's part A and the work for it. What about part B? Does the data support the conclusion that A's velocity is negative 100 at some point on 5 to 8? Well, since V is differentiable, it must be continuous, and because V is continuous on 5 to 8, IVT says V must pass through all values from V of 5, which is 40, to V of 8, which is negative 120. Well, between 40 and negative 120, therefore V at some time must equal negative 100 at some time on 5 to 8. Okay, so that's part B. What about part C? At time equal 2, train's position is 300 meters east of origin station and moving east, going that away. And x of 2 equals 300 meters. Okay, then they say find x of 12, and they say we should use a trapezoid sum with 3 subintervals. So I know x of 12 minus x of 2 equals the integral from 2 to 12 of v of t dt. They want me to approximate this integral by using a trapezoid sum from the table. So I see 3 trapezoids, 1/2, 5 minus 2, base 1 is 40, base 2, 100, plus 1/2, 8 minus 5, times negative 120 plus 40, plus 1/2, 12 minus 8, negative 150 minus 120. That's what that integral is equal to, x of 12 minus x of 2. We know x of 2 is 300, so x of 12 is going to be all this stuff plus 300. And when I compute that, I get negative 150. Yes, you could leave your answer like this. However, in part D, we're going to need to plug this number in somewhere, I think. No, we don't need to plug this number in, but we do need to, yeah, I'm just going to shut up. Okay, so there's x of 12. Great, and that was part C. Let's see, what about part D? Part D says you've got a second train moving north, and at time equal to 0, velocity is positive. So, oh, but what about position? Is 400 meters north. Okay, so I've got B traveling this way, B, and I've got A traveling this way, and we've got a distance between them. And so we know that a squared plus b squared equals d squared. But remember, this is the position of a as a function of time. And so when I take this derivative, it's not just 2a. That's the derivative of the outside. Now I need to come back and find dA dt, which is the change in position with respect to time, also known as v sub a, 2a plus 2b times, don't forget the derivative of that inside function, dB dt. And that's the change in position for b with respect to time, which is v of b. And that's going to equal 2d times, again, chain rule, dd dt. This is the thing we're looking for, the rate at which the distance between these objects is changing. So I must know everything else. Well, you know, I see B and I see A. I can plug those in. V of A I can get from the table. V of B, I'm going to use the velocity equation that they gave me for B, and I'm going to plug a number in there. But what about D? Oh, there's D, and I've got these sides, so I'm going to use my Pythagorean theorem, or Pythagorean triples, to find out that this is 500. So I've got 2 times 300, and we want to know the velocity at time equal to 2. Velocity at 2 is 100. Plus 2 times 400. Velocity at 2 for B. So velocity for B was given by this polynomial function, negative 5t squared plus 60t plus 25. And I want V of 2. So that's 4, or negative 20, plus 120 plus 25. And so I get VB of 2 is 125. So this is 125 equals 2 times 500 times dd dt. So if we're looking for dd dt, we want this stuff divided by 1,000. Okay, and we can leave our answer like this. We don't need to do anything else. They just want meters per minute. Great, that's problem number 10. We've got 2 problems left. Let's take a look at those. Problem number 11. V is given by 1 minus tangent inverse of e to the t. Please, God, let this be a calculator problem. Yes, it is, with calculator. Ew, who would want to do anything with that by hand? Okay, find the acceleration at time equal to 2. So I want a of 2, which is dv dt evaluated at t equals 2. And I don't have to set up anything more than that. I just need to go over to my calculator and type in 1 minus inverse tangent e to the t, close two parentheses. Now I need the derivative of this function, y1, comma x, comma at time equal to 2. And I get negative 0.133, negative 1.33. Okay, part B. B says, is speed increasing or decreasing at time equal to 2? So I need v of 2 and a of 2. Well, I already know that a of 2 is less than 0. Let's find v of 2 by using our table. And I plug in a 2, and I get v of 2 is negative 0.436. That's less than 0, since v of 2 and a of 2 are have the same sign. Speed is increasing. Okay, part C. Part C says, time at which the particle reaches the highest point. Justify your answer. So, and we're looking at time greater than 0. So, my viewing window 0 to 3. I don't know if that's going to be big enough, but let's see what this graph looks like. I got a maximum there. Ooh, and then my graph is just negative, negative, negative. And that's nice. So let's find that point. So I can calculate 0. Go to the left side of that point. Still not there. There we go. Enter. Enter, enter. So I've got 0.443 is a critical point. And we're positive here and negative here. We're asked, is the particle reaches its highest point? And then they say justify the answer. Okay. Well, I have a minimum here, and I have a minimum here. This goes on forever, so it just goes lower and lower and lower. And I have a maximum here. So particle reaches highest point at t equals 0.443 because to the left of t equals 0.443, v is greater than 0, and to the right of t equals 0.443, v is less than 0. Okay, so there's part C. And what about part D? Find the position at time equal to 2. Okay, so I know that x of 2 minus x of 0 equals the integral from 0 to 2 of v of t dt. We're told here that time equal to 0, y is negative 1. So we know x of 0 is negative 1. Okay, I'm going to find this integral with my calculator. Math, integrate. Oops, let's get to the main screen. Math, integrate y1, comma x, comma 0, comma 2. Then x of 2 minus a minus 1 is plus 1 equals negative 0.3606887. And I want to subtract 1 from that, so I get x of 2 equals negative 1.361. Okay, so the position is negative, and what about v of 2? If I plug a 2 into this function, I find that v of 2 equals negative 0.436. So I'm below the origin and I'm moving away from the origin. So below and moving away at time equal to 2. Um, particle is below the origin and because v of 2 is less than 0, it is moving away from the origin. Okay. Let's see. 12. 12, our last problem. It's another with calculator. Phew. Ugh, look at those functions. Okay, is speed increasing or decreasing at time equals 5.5? So I'm going to put in both of these functions. I'm going to put velocity to sine of e to the x over 4 close two parentheses, and acceleration, that's 1/2 e to the x over 4 times cosine of e to the x over 4. Okay, so I've got velocity in 1 and acceleration in 2. I'm going over to my table and I'm plugging in a 5.5. And so v of 5.5 is negative 1.453 and a of 5.5 is negative 1.359. 359. Since a v of 5.5 and a of 5.5 have the same sign, speed is increasing. Okay, there's part A. What about part B? Find the average velocity. So I want 1 over 6 minus 0, integral 0 to 6, v of t dt. I want the average value of the given velocity function. I'll use my calculator to figure that number out. I want to do the integral of y1, comma x, comma 0, comma 6. And that's times 5.6962,802. And if I, don't clear that number, second answer. Phew, divided by 6. I get 0.949 is the average value. Whoa, I had a different number before. Why is that? Average velocity for the particle on 0 to 6. Average velocity, yes, average value of the given velocity function. And did I type it in properly? Let's check. Velocity 2 sine e to the x over, plus 1. Plus 1. Dope. Okay, so I need to add 1 to that number. Let's just check that for a second before I boldly do that, because this number is going to change now. So we'll go back here to this, and we'll get 11.6962802. So this is the number we want to divide by 6, and I get 1 point. Okay, so there's the average velocity. So we want to see the calculus set up, but then just use your calculator. Part B is done. Part C, find the total distance traveled on 0 to 6. Okay, so let's take a look at the velocity graph. I don't need acceleration for this, just velocity. And they tell me the time interval is 0 to 6. So let's graph velocity on 0 to 6. Oop, I see one place where velocity changes sign. Second, calculate 0. Okay, enter, enter, enter. So t equals 5.1955223. Okay, that's when velocity goes from positive to negative. V, 0, 6, and this one critical point. Okay, what do they ask me? They ask total distance traveled. So I'm going to say total distance equals the integral from 0 to 5.1955223 of v dt minus the integral from 5.1955223 to 6 of v of t dt. I'm not going to do anything else with calculus. I'm just going to go to the calculator and compute these integrals. Math, integrate y1, comma x, comma 0, comma 5.1955223. And then I want to subtract from that the integral of y1, comma x, comma 5.1955223, comma 6. And I end up with 12.573. 12.573 is the total distance traveled. And then the last part of number 12 is find the position when the particle changes direction. Well, we said that the particle changed direction at 5.1955223. We went positive to negative there, and so they want to know the position at 5.1955223 minus x of 0 equals the integral from 5.1955223 of v of t dt. So x of 0 was given to me as 2. And so I'm going to add 2 to the value of this integral. And integrate y1, comma x, comma 0, comma 5.1955223. And I want to add 2 to that number. And so I get 14.135 equals x of 5.1955223. All right, we're all done. I hope this was helpful in going through this. Certainly, I'm sure you know whether or not an object is increasing or decreasing at this point.